piecewise functions. Functions as that define different pieces over. If I have a function f is equals to, I might have x, and then I might three different. About your piecewise function is that because I have three different values, I need to know which one to choose, and so you have what's called a decision tree. A decision tree is a rule that's based upon the x value that tells us which of the three pieces to use. They're always mutually exclusive. So for instance, this might be, I'll use this piece right here when x is less than or equal to -1. I'll use this piece right here when x is between -1 and 2. And I'll use this last piece down here when x is greater than 2. And so what happens right here, this right here is called your decision tree. And it's used to tell you when to use this function as opposed to when to use this function. Let's say I want to find f of -7. Well, is -7 greater than 2? No. Is -7 between -2 and -1? No. Is -7 less than -1? Yes. And so I will use this right here. And so f of -7 would be 2 times -7 minus 2, which is -14 minus 2, which is -16. Again, some of the harder times right here is you have to watch your boundary values. If I ask you to find f of 2, well, clearly there's a 2 here and there's a 2 here. So which one of these two functions do I use? You use the one with the equal sign, which is equals to 4. Piecewise functions, plugging them in. You never plug into all of them. Remember, if you had to graph this function, that actually requires a lot more detail. So I have my function again, f of x is equals to, I will have 2x minus 2, x squared, and then x plus 3, and then I will have x is less than or equal to -1, and then x is greater than 2. To draw this graph in a piecewise sense, what you're going to have to do is draw all three graphs and then overlap them carefully. So, let me see what I mean. So I go this way, and I go across this way. And the first graph I'm going to draw right here is this graph right here, 2x minus 2. This graph right here has a y-intercept of -2 and has a slope of 2. So from this point right here, I'll go up to and over, I'll go up to and over 1. And so this graph of this function right here will look like this. It's not a lovely graph. Let's go up a little bit more. That's my first graph right here. The next graph right here is the x squared graph. That's a parabola, which we saw in the previous section. And your parabola looks like this. Curve right here. So that's your parabola. And then your last graph, your x plus 3 right here, has a y-intercept of 3, 1, 2, 3, and a slope of 1, so you go up 1 over 1. And that gives us our third graph right here. Well, I have 3 graphs, but clearly I cannot use all 3 graphs all the time. In fact, we know we can only use 1 graph at a time. And so then we go to our boundaries. Our first boundary is at -1, and our second boundary is at 2. So 1, 2, actually right here. And what the boundaries do is the boundaries tell us which graph to use, while which graph not to use. the final graph will be in white. So when I am less than 1, I am using the light blue graph. So you see less than 1 right here. This section, this piece of the graph over here that I am now covering, that right here is the first piece of the graph right here that I am looking at. Now, I have to look at this boundary value very carefully because it's a closed circle, because it's a equal sign. I have to use a closed circle at the boundary. So let's make it very nice and neat. A closed circle right here. Now, if I am between -1 and 2, I switch over to the parabola. So starting right here. Now this right here, I do not have an equal sign, so it's going to be an open circle on this side right here. And on the other side, I do have an equal sign, so it's going to be a closed circle right here. And my graph for my piecewise function right here will look like this. As you can see, the graph is very disjointed. It has its first piece down here, but then the second piece has the parabola way up here. Last but not least, when I am greater than 2, I use the purple graph. And so at this point right here, my purple graph right here, I'll have an open circle for my purple graph right here. One color. Open circle right here, and then I go the rest of the way, and that's my purple graph right here, like so. Now I remove the old graphs because I don't need them anymore. And what I am left with in white is your piecewise function. Of course, you need to be very careful when calculating your piecewise function, but that's the essence of graphing 1. It is sometimes important to be able to find the boundary values, so let's go ahead and see if we can find the coordinates. Let's see if my rough sketch got close to what we're looking at. So this first boundary point right here is -1, comma. I plug -1 into the function, into this function right here. And -1 times 2 is -2, minus 2 is -4. And so the coordinates for this point right here is -1, -4. This point right here. Then the next one right here, I will plug -1 into the x squared. Notice right here it's not equal to, but still I plug it into the x squared anyways. And when I plug -1 to x squared, I get 1. So the coordinates of this open circle is -1, comma, -1. Yes, an open circle can have -1, 1. Yes, an open circle can have coordinates. And then on the other side, when I plug in 2, I get 4. When I plug in 2, I get 4. And so I'm plugging 2 into the x squared. So the this closed circle right here is 2, comma, 4. And then last but not least, I plug in 2 into the last equation, and I will get 5. So that means my last graph is slightly below the let's see if I can fix that then. The parabola should look like this. Closed circle right here. 2, comma, 4. And the points for this one right here should be 2, comma, 5. There we go. And that's our piecewise function. Piecewise!